Hi friends, this is Prashant. Today we are starting with third chapter, standard 9, and in that third chapter it is part E, that is gravitation. Now here you have Newton's law of gravitation. This part is Newton's law of gravitation. Now what is Newton's law of gravitation says? These are two bodies. This is first body. This is second body. They are separated by, say, distance r, right? Mass of first body is m1 and that of second body is m2. Mass of first body is m1, mass of second body is m2, and they are separated by distance r, that is from center of first body to the center of second body. Now, according to Newton's law, every body in the universe attracts every other body. Every body from the universe attracts every other body with a force which is directly proportional to F, is directly proportional to product of their masses. Force is directly proportional to product of their masses, m1, m2, and it is inversely proportional to square of the distance between them. It is inversely proportional to square of the distance between them. This second statement, this is called as inverse square law. This is called what? Inverse square law. What do you mean by this law? If you increase the distance, force will decrease. If you increase the distance, force will decrease. Now if I combine these two, so then there will be F is proportional to m1 m2 upon what? R square, right? If I remove proportionality, then I will get F is equal to some constant G. This is m1 m2 upon what? R square. Now this is the formula for gravitational force, right? Now here where G is called as universal gravitational constant. This is different for small g. This is capital G, is universal gravitational constant whose value is fixed, that is 6.67 into 10 raised to minus 11. Unit will be, it is Newton meter square upon kg square. It is Newton meter square upon kg square. Now from where we got this unit? So I can write this as G is equal to Fr square upon m1 m2. So force is Newton, distance meter square, kg into kg, that is kg square, right? This is the part. Now this constant is applicable for any two bodies on the surface of Earth or in the universe. It is applicable anywhere, right? Now, what are the characteristics of this Newton's laws? This gravitational force characteristic is that first, this force is the weak force among all the basic types of force. So right here, what is the characteristic of this force? One, this is the weak force among all the basic types of forces, right? This is long range force. This is the long range force. This is applicable for two bodies, heavenly bodies, not for ordinary bodies. I'll come to this one. And this force is always attractive. This is always attractive. It cannot be repulsive. And it obeys that inverse square law. If you increase the distance, right? So we can say force is inversely proportional to distance square, right? If you increase the distance, force will decrease. If you decrease the distance, force will increase, right? This is about the part. Now we'll go with the next part, that is how small g and capital G are related, right? And there is one more thing related to this part in the same chapter, same part, that is if I write this part as, say, what is, there is a term called as F12 bar, right? What is F12 bar? That is force acting on body 1, right, by body 2. It is force acting on body 1 by body 2, right? This is first. and second there is a F21 bar, that is force acting on body 2 by body 1, right? So if I write this part, so I can write this as F12 bar is equal to minus of F21 bar, right? They are equal in magnitude, opposite in direction, right? This is the part. This is according to Newton's third law. For every action there is equal and opposite reaction. Now check the next part. Next part is about relation between small g and capital G, right? This is the again 2-mark derivation they can ask, and based on this you have different questions. Now check that part. What is that relation? You have, it is relation between small g and capital G, right? Check. Consider a body. So this is our Earth of radius r, right? Mass m, right? This is the body kept on the surface of Earth. Mass of this body is m, mass of Earth is capital M, radius is capital R, right? Now according to Newton's law of gravitation, gravitational force, right? Gravitational force F is equal to, it is Gmm upon r square. Because what is the gravitational force? G m1 m2 upon r square. M1 is capital M, m2 is small m, and distance r was capital R. Right? This is the equation number 1. Now, what is weight of body? See, I am saying what is my weight? Is nothing but the gravitational force that is equal to m into g. That is equation number 2. Now, we know that what is my weight is nothing but the gravitational pull of Earth on me. What is my weight is nothing but what? Gravitational pull or force of Earth on me. So I can write here, therefore, your weight is equal to, this is gravitational force, right? So I can write here, therefore, mg is equal to gmm upon r square. So I can cancel this mm. So I will get g is equal to what? Gm upon r square. G is equal to gm upon r square. So from this we conclude that acceleration due to gravity g is independent of mass of body. It is independent of mass of body, right? But it depends on g depends on what? Mass of planet. So over here it is Earth, and g depends on radius of the planet. Radius of planet, right? Radius of planet. This is the 2 part. Now it is directly proportional. G is directly proportional to mass, and g is inversely proportional to r square. Now this part is important for us, the square part, right? Inversely proportional distance square. Now our Earth is not exactly a sphere. Earth is not exactly a sphere. It is a geoid in shape. That is, it is flattened at pole and it is bulges at equator. Not like this exactly, but I am just showing just to distinguish that part. So here this is the radius at equator. This will be the radius at pole, right? Since your radius at equator is more than radius at pole, so we can write your g at pole is more than g at equator. Now what is the actual value? Actual value of g at pole is 9.83 meter per second square, and g on equator is what? 9.78 meter per second square. But for on an average standard value on the surface of Earth is taken as g is equal to 9.8 meter per second square. So it is, we are assuming that Earth is a perfect sphere, then we will take g as 9.8 meter per second square, right? Otherwise we will take g as g on pole is 9.83 and g at equator is 9.78 meter per second square. Why? Because radius at pole is less as compared to radius at equator, right? Therefore g will be more inversely proportional, right? We'll go with the next part. Check. Next you have Now next you have studied in second chapter 3 kinematical equations. We have studied 3 kinematical equations. What are 3 kinematical equations? That equations were first equation tha V is equal to U plus AT. This was first equation. Second equation was S is equal to UT plus half AT square. Right? And the third equation was V square is equal to U square plus 2AS. These are 3 different equations. Right? Here we'll use the same equations, but if body is at rest and it is freely falling, right, freely falling in a downward direction, then what will be? It will be the case. So if the body is at rest, matlab u equal to 0, and it is freely falling, matlab a is equal to g, right? And say displacement is equal to hamara h. Displacement will be h. So I can write here, therefore this is v is equal to 0 plus gt. So this is v is equal to gt, right? Second equation becomes s is equal to, this is 0 plus half, this is gt square, but instead of s I will write h. So you will get here h is equal to half gt square. This is the second equation. And for third, v square 0 plus 2gh. So you get here v square is equal to 2gh. This is the third equation, right? So you have v is equal to, this is gt, h is equal to half gt square, and v square is equal to 2gh. These are 3 equations. Now second case, if, right, if body is not at rest, right, that is u is not equal to 0 and it is sent against gravity and it is moving against gravity. It is against gravity. So in that case, what will happen? Just check. Here v is equal to u minus gt. Right? V is equal to u minus gt. H is equal to ut minus half gt square. And here v square is equal to u square minus 2gh. So these are 3 different equations where your body is thrown against gravity and your initial velocity is not equal to z. Right? Now what will be the next part? Next part is the difference between mass and weight. Right? What is the distinguish between mass and weight? Now mass is defined as the quantity of matter contained in a body. It is a quantity of matter is a mass. But when I say weight is nothing but it is the force of gravity that is equal to weight. W is equal to m into g. It is a force acting on a body by the earth, that is called as weight. Right? Now mass will not change, it remains same everywhere. If you take any object from one place to another whose mass remains same. But if you consider weight of body, that weight of body will change because weight depends upon acceleration due to gravity. Right? If you consider a body, it is taken on the surface of earth, its weight is fixed. If you take that body at the center of earth, weight becomes 0. But mass at both the places remains same. If you take that body to certain height, then also its weight will decrease, but mass remains same. If you consider one body, same body on the surface of earth and surface of moon, so on surface of moon its weight will be less because their acceleration due to gravity is 1/6. Acceleration due to gravity kitna hai? 1/6. Right? That is the difference. Right? But mass remains same. Now next will be unit. That unit will be, there are 2 units. One is in MKS system. In MKS system, gravitational unit of force is called as kgf. In MK system, gravitational unit of force is kgf, kilogram force. Now how they are related? The 1 kilogram force is equal to g Newton. It is what? G Newton. Now how it is coming? So we have force is equal to m into g, right? So I will consider, how will you define 1 kilogram force? It is a force acting on a body of mass 1 kg. It is a gravitational force acting on a body of mass 1 kg. So I take here, this is 1 kgf is equal to, mass will be what? 1 kg into g. Therefore it is 1 kgf is equal to, this is g, that is g Newton. This is g Newton, right? Okay. Now here g ka value will be either 9.8 Newton or it is taken as what? 10 Newton. Whatever is given, that you have to consider, right? This is 1 kgf. Now what is gf ka relation? So 1 gf is equal to 980 dyne. It is 1 gf is equal to 980 dyne, right? That's it for this video. Please, I hope you like this video, and please subscribe my channel so that I can make you more videos. Thank you.